All right, guys, so now we're back and we're looking at more inequalities that have variables on both sides. So I already talked to you about what can happen. They split this up in the book, like they have their typical and they call these ones special. I don't see them as special, I see them as different. So remember, you can have your typical, which is you would have a ray going in one direction. You can have what is in a sense another identity. They don't really call it that, but you notice every single number works. This is when you end up with a true statement at the end of your solution. This means no numbers work, and you end up with a false statement at the end of your inequality. Typical is just where you end up with a statement. So remember, the whole point of all of this is we are searching for numbers that we can plug into our variables. I had us copy it down. I had us say it in class several times. The solution to an equation is any value for the variable that makes the original statement true. Maybe everything works, maybe some stuff works, maybe nothing works. That's just how the cookie crumbles. Let's see what these problems tell us is going to happen. So now let's look at A. 8b minus 3 is greater than 4 parentheses 2b plus 3. Well, if I was following my steps, I look for distribution. I know I've got some because I see the parentheses. So I have to distribute this 4 to the 2b and to the 3. So we end up with, 8b plus 12. Now I double click that button. We want to get our variable on one side. Well, look, if I want to remove this variable, I have to subtract 8b. I do it from one side, I do it to the other. But notice, when I do that, all my variables drop out. Anything minus itself is 0. There are no more b's left. I end up with negative 3 is greater than 12. So think about that. I end up with a statement at the end. So I know this is not going to be a typical type of problem. But negative 3 greater than 12, is that true? That is not a true statement. What that tells me is there is no number that can ever make this inequality work. Okay? So now, they're not even going to bother. If I was going to draw the number line, and let's say on a test, I give you a number line under this problem, and I say, fill out the number line, you wouldn't write anything in the number line. Just make sure you write no solution. I'm trying to trick you, and it's possible. I could put a number line there. You're just expected to not fill it out. Okay, let's look at the next one. Well, I know I'm going to have distribution here because I have my parentheses. So it's 2 times 5w and 2 times negative 1, which gives me 10w minus 2 less than or equal to 7 plus 10w. Now I'm going to get rid of my variables. Minus 10w on each side. Negative 2 less than or equal to 7. I am now staring at a true statement. I'm looking at negative 2 less than or equal to 7. That's true. If this is always true, then this is always true for every variable, every value of w you can think of. In other words, the solution is all real numbers. And let's see if they try and graph it this time. They don't. So all you would do is you would take your graph and you'd fill out, shade, the whole thing. And you'd have arrows going both ways, okay? It wouldn't go from a point, it'd go your whole line. All right. So that's a quick overview of some of these problems. I'm going to throw down a couple extra just for the next set. I want you to see a couple more because I know some issues that are going to come up. So I'm going to have another video called Extra Problems. It's not stuff for your notes. It's going to be before I get to the story problems. So just make sure you check that out, okay? Thanks, guys.